In the name of God. Hello, dear students. Welcome back to Fairflow's website. My name is Masood. I'm a physics teacher. I'm at your service to explain physics curriculum grade 11. So far, we talked about in previous lessons, we talked about two properties of displacement. Right now, we are going to discuss questions regarding these properties. Right. Question number one. Why is displacement equal to zero in the case of retreat? Nice question. Why is displacement equal to zero in the case of retreat? In the case of coming back, for example, think about a gecko, right? Think about a gecko, for example. It moves from a position to the other, this xi, right? And after that, it doesn't stop and it returns back immediately and it, let's say, retreats to its original position. That's why initial coordinate and final coordinate would be the same in this situation. So let's discuss the answer. Let me read the question for you again. Why is displacement equal to zero in the case of retreat, in the case of coming back? Because initial position and final position will be the same. Because xi mathematically is equal to xf. And whenever you want to calculate the delta x, so xi minus xf would be zero, right? Question number two. Mostly distance is less or more than displacement. So there are two options here. Think about it. It's a nice question. It's a very accurate question. If you didn't understand the previous properties, you cannot answer this one. Mostly, yeah, often, distance is less or more than displacement. Displacement sometimes becomes zero, right? Especially in the case of retreat. But distance becomes twice. That's why, uh, let's say, distance mostly is more than displacement, right? You cannot say always, mostly. Mostly is equal to is more than displacement. This is about number three. On a straight path without retreat, one-way trip, right? On a straight path without retreat, displacement is equal to what? Without retreat, for example, the gecko moves from here, from xi to xf, right? It doesn't return to the original position, so without retreat, one-way trip, right? In this case, I want you to calculate the displacement. Teacher, displacement will be xf minus xi. Calculate the distance for me. The same, right? It's the same. That's why in the case of without retreat, displacement is equal to distance. So there's no difference between displacement and distance without retreat because there's only one-way trip, especially on a straight line, right? On a straight line. Without retreat, displacement is as the distance, right? Number four, on a straight path with retreat, with coming back, with return. On a straight path with retreat, right? The object moves to its original position. Displacement is, yeah, if the object moves to its original position. Think about, for example, yourself. You wanna, for example, travel to another city. You start your trip at your home, right? You take out your car from the yard and you start your trip. And after that, for example, after 1 day or after 2 days, you come back to its original. You come back to your original position. You park. You will park the car at the same position where it was actually where it was, right? So that's why uh, in the case of retreat, In this situation, and whenever you think about the same example, you travel to a city, and after that, after 2 days, you come back to your home. You park your car in your yard, right? So in this case, you park the car in the same position. That's why in this situation, as if you, as if you didn't, let's say, you didn't have any displacement, because because you will because you return to its original position, to your original position. In this situation, displacement becomes zero, and distance becomes what? How many kilometers, let's say, are there between two cities, your, between your city and this and your destination? For example, say, teacher, 100 kilometers. So you travel 100 kilometers distance, and you come back 100 kilometers distance as well. That's why distance twice. Becomes twice. Keep in mind that in the case of retreat, with retreat, in the case of retreat, displacement is equal to zero, as if the object does not move, right? But distance becomes twice, becomes double, right? Number 5, in the following figures, there are some figures I prepared for figures for you. Determine the routes which represent the distance and displacement. So what's unknown here? Uh, you are asked to determine the distance and displacement. Right? There are some paths. Let's discuss them together. Number 1, for example, A. I want you to tell me which one is distance and which one is. There's a, for example, mountaineer, or there's a tourist or passenger, any let's say person. The person tends to what? Tends to climb up the hill, right? So it follows this path. It follows a curved path. So, and so is this distance or displacement? Number 1, I told you distance might not be a straight line. Distance might not be a straight line. What does it mean? So distance can take a curved line, can take a zigzag path. It contains a circular track. So distance can take any route without, let's say, regarding the regardless of the shape of the track, right? So it takes any route. That's why the number one becomes distance, right? Think about for example, for the same tourist, right? For the same tourist, I want you to calculate the displacement for the tourist whenever it, let's say, it climbs up the hill, and it goes up, and it goes down, right? It goes down to the other side. For example, the person reaches here, right? This is his or her path. In this case, you have to draw a straight line in order to find the displacement. I mean, because displacement should be a straight line. Displacement is always a straight line. It's a shortcut, smallest path, smallest path, smallest actually path that is followed by uh, followed by a moving object. That's why this straight line from here, from the starting point to the ending point, is called this is called displacement, right? Displace Displacement. So here we can let's say deduce another result. Compare between the distance and displacement for the same tourist. Yeah. So distance is more than the displacement, right? Whenever you measure the distance, you observe that the distance is more than the displacement. That's why we say we have a note often or mostly distance is more than displacement. Often. We don't say always, often. B, we have a zigzag path and we have a straight line. There's a particle. This particle actually follows follows a zigzag path. So, is zigzag path considered displacement or distance? I'm sure you know the answer. The zigzag path is considered a distance, right? The particle travels the distance and it reaches here. So I want you to tell me about the straight path. Whenever you draw a straight line from the starting point to the ending point, this straight line is called displacement, right? Displacement. So compare between the two paths for the same particle. Is displacement, let's say, more than the distance or vice versa, right? Uh, or is displacement more than the distance or distance more? Actually, compare between these, let's say, quantities. Here we can say distance is more than displacement, like the previous case. C, there's a car. The car, let's say, moves along an arc, right? It tends to, let's say, to follow, let's say, this circular track, right? In this situation, number one becomes distance. Why? Because it's not a straight line, right? Because distance can take any route, I told you. But number two becomes displacement because it's a straight line. Because displacement must be a straight line. So how do you uh, find this path actually? You have to draw a straight line from the starting point to the ending point in order to find the displacement. And you see that the displacement is less than the distance in length. Go to the last one. The car, let's say, circles the square. There's a square and the car circles it. Right. So we have a circular track. Circular track is considered a distance, right? Because distance can take any route. What do you say about the uh, straight line drawn from the initial position of the car to the final position of the car? For example, the car reaches here, right? Whenever the car reaches this position, in this case, actually, displacement is considered a straight line. Number two becomes displacement. That's why displacement is a shortcut. Is a shortcut followed by a moving object. Thank you very much, guys, for watching this video, and bye for now.